Well, hello and welcome to part 3 of our restoration video of the Marantz 2500. Now that we have the power supply and the main power amp module pretty much finished, we're going to focus our attention now on this video on taking care of the chassis and getting it all cleaned up, and then also looking at the soft start circuit and the protect circuit for the speaker protect. Doing a couple mods to them and also rebuilding them. So the first thing that's pretty cool about these receivers is to service the back panel, you just take 4 screws out. If you look, there's 1, 2, and then 2 on the other side, and then on the side you loosen these little screws here on the side, and you can kind of see how those are slotted holes, and the whole thing just swings down, kind of like the door of your oven. So it makes it really easy to service it. And as you can see, this fan is pretty bad. It works, but it's pretty gross. We're going to replace it with a new one that is a little bit quieter, has very similar airflow, and has a ball bearing instead of a sleeve bearing, so it should last pretty much the life of this receiver, hopefully. And we're going to go over all the connections, make sure they're good, clean everything really thoroughly, and that should be it for this video. So we'll see what all we get done, and if that sounds interesting to you, stay tuned. So the first thing I'm going to start with here is getting this fan out of the way, because it's kind of big and dirty, and we have a new one. So that's pretty simple. We're going to take these mounting screws out, and even though this is really dirty and it's a lot of cleaning work, it sure beats cleaning used barium out of a fluoro table. Any of you x-ray folks out there are cringing right now that I said that. Some of you might be saying, what's that? But no, this isn't actually too bad. I actually enjoy doing this. So we'll get this thing out of here. And there are many different choices you can choose for a fan. The thing you have to remember if you're going to buy a new fan for this is when you look at the specs, and you can go on to all the favorite haunts, you know, like Mauser, DigiKey, MCM, whomever. And the main thing you want to look at is make sure the fan has decent airflow. You want a medium airflow fan. If you get too high of an airflow, then the noise gets ridiculous. You can see that this is a 16-watt fan, so you want to kind of stick to that wattage, and the main reason you want to stay in that same ballpark, anywhere from 14 to 18 watts, is because the resistor that's in series with this to run it into low speed is affected by that. Also, the lower wattage fans typically have lower airflow, and usually these fans of this diameter, and just to give you an idea what this is, you can see it's a 120 millimeter fan for the most part, and it's about 40 millimeters. Am I off the camera? I'm sorry, guys. About 40 millimeters, 38 millimeters, roughly 38 millimeters looks like, by 120. And this is this particular one runs on 115 volts, 50 or 60 hertz, and again it's 23/16 watts, and that's based upon the mains frequency. And the airflow on these I don't have, but I would imagine you want your max airflow to be somewhere in the 80 CFM or something like that. I forget what the spec was on the one I picked. I actually kind of researched it a little bit. But the main thing you want to know is some of these fans don't like to work very well on lower voltages. So if they're a 115 volt fan, and you try to run them at a reduced voltage like 80 volts, some of them don't work properly. other ones do. So, and that is a spec that you can look up when you're looking at the fans online. You want to make sure that it'll run, you know, down in that 60 to 80 volt range, so that when that speed reducing resistor comes into play, the fan still operates properly. And you want to make sure that it's a quiet fan. They all have a dB rating for noise, and of course the lower the dB rating, the quieter the fan will be. But also you'll find that the lower the dB rating, the lower the maximum airflow will be. So it's a trade-off. So you want to kind of pick a middle of the road one that's quiet. And they do have fans that have higher airflow but are a little bit quieter, and that's kind of what I tried to stick with. So I'll show you the one I got here in a second. Okay, here's the new one that I went with, and again, it's a 1715 watt, so it's similar. Ball bearing, that's pretty important. There's ball bearing fans and sleeve bearing fans, and some of the sleeve bearing fans are the lower cost ones. Typically the ball bearing ones are better, not always, because there are different bearing technologies, but as a general rule, the ball bearing fans are a little bit better quality and they last longer. Here's the model number. It's made by Orion. I purchased this one, I believe, through DigiKey, but you can also get them through Mauser's and a lot of the other places, wherever you can find it for the best price. It's a metal framed fan instead of plastic. I kind of prefer the metal frame fans. They don't tend to flex as much and bind when you tighten the screws down. They're a little bit heavier, but and you can see the shaped fan blades. This is actually a low noise fan, so it's still, you can hear it, but it's actually not too bad when it's at full speed. So that's another important thing, and it does throw a lot of air. So there you go. Okay, so we're working on the fan and the soft start circuit, and this is the resistor for the soft start. These are the old ones, and they actually used to be mounted down here, and I just took an aluminum plate and I mounted, as you can see, our replacement resistors. Now for the soft start circuit, which is what is in line with the mains transformer during power up for the first split second to soften the the inrush current, they're using a 10 ohm 10 watt resistor, and this resistor is notoriously undersized for this purpose, and many of them blew open, so that actually can cause some problems. So we're going with an aluminum body 25 watt 12 ohm resistor and mounting it to this little aluminum. Now this is no big heatsink, but it only has to carry the current for just a second, so this is more than adequate. The other resistor is a 680 ohm, and this is the resistor that drops the mains voltage down to a smaller voltage for the fan to make the fan run at lower speed and lower noise. So I didn't have a 680 ohm, and these can get quite warm when they're dropping the voltage for the fan, because they actually have to dissipate some actual power. So I did have a 470 ohm and a 200 ohm. So I put them in series, wired them up, and I measured it, and I'm getting 673 ohms. So that's pretty good for 680. So that'll be more than enough. And with the aluminum chassis mount resistors like this, that'll really dissipate the heat very, very well, and it should give us a lot cooler running resistors. And this is going to be mounted right in front of the cooling tunnel, so the airflow moving across into the cooling tunnel will also help keep this cool. So this will never have any thermal problems. And then on the side here is where the socket will go, and we're going to replace the soft start relay with a brand new one, and that'll take care of that. And this thing will be all set to go. Now, when I was in here, another thing I noticed was I had this thing flipped up out of the way, and if I zoom you in, you can see this receiver has had some work done on it, and in several places as well. So if we look we can see right here where they have a kind of a bodge repair job. And of course down here, that one right there. So this amp has, I believe, has been in the shop more than once. It's probably been serviced a couple of times. Nothing looks terrible or anything, but it's definitely had some work done on it. You can tell by all the flux on the board that they've kind of touched up some of the joints that may have come loose from the controls. This board really isn't stabilized. Let me back you back out. Isn't really stabilized very much in here. It kind of hangs by the components, so I'm sure that after enough time some of these connections have worked loose, and you can even see down in here some of the solder joints aren't all that great. So we're going to go over and we're completely redo those boards underneath, and just a little bit at a time, that's all. Okay, so we've got this all mounted down and everything looks good, you can see. And we're moving on to the speaker protect board, which is this little board here. Not much to it. And I've taken out the speaker protect relay, and it has been pried open before. And I got it out of here, I got it apart, and I took a look and noticed something interesting. If you notice, there are actually only two terminals under here. So you have, one here and one here. So there's your normally open contacts right there. But if you look on the top, there's actually two separate tabs and two sets of contacts, a smaller one and a larger one. These are called bifurcated contacts. For real, I'm not kidding. And the reason for them is these contacts actually come in at different times, really at near the same time. But the idea is it will spread the arc, and it will also spread the current between the two sets of contacts. So it makes these a little bit more robust than just a standard single contact relay. You don't see them very often. You can still get them, but they're special order. The unfortunate thing is this relay has been worked on, and I don't think I can get you zoomed in close enough to see it, but they really scratched up the contacts. Somebody had tried to clean them, and let's see, I don't know if I can do this on camera. Awkward as an ostrich in a porta potty here. But if you look down, maybe you can see that. You can see all the scratches all over that. It should be very polished and smooth, and somebody really scraped the heck out of it. Probably used sandpaper or something trying to clean it. And I know I've said this before, I am not an advocate for cleaning contacts on these. And the reason I'm not is I've just kind of learned over the years from my work that these relays have plating on the contacts. And it's usually a very thin coating of that plating. And when you sand them and burnish them, clean them, anything except just cleaning off surface tarnish with a chemical type cleaner, like taking a little piece of card or paper and soaking it with some contact cleaner and just, cleaning it that way. Anything abrasive will ruin that little coating on there, and then it will just make it tarnish all the faster. The other thing is, when those contacts aren't completely polished, you have those little micro scratches in there, and when these come in, they don't make as good of contact. They make little tiny arcs, and those little tiny arcs actually will build up over time and actually destroy the contacts even faster. So I'm just going to put a new relay in, and I don't have a set with bifurcated contacts, but I do have one with heavy-duty contacts that'll work perfectly in there, and that's what we're going to use. So let me get that, and we'll get it in there. I just thought you'd be interested in seeing this because you don't see these kinds of relays very often. Again, being special order, but they are very good relays. Okay, and there's the new relay if you want to look at the actual part number on it. And just in case you wanted to look at the part number I used for that one, for the soft start. There it is. So to give you an idea. And that board's all done. She's all set to go. So little by little, we're going to start on the front part of the amp now and then work our way around. Nice. So I did all the contortions to get this tone control board out, and we have a little guest. Let's see if we can see him. Right there. There's a bug in the system. I don't know what that is. Cockroach? I don't know. He's gross. Nice. Yummy. Okay, so we got some cleaning to do, and I guess we'll get started. Yeah, this has definitely been worked on. You can see where some of these solder joints aren't even closed off. They're just barely on there. So we're going to see if we can clean that up a little bit. Oh yeah, we got another bug. This one was hiding in the volume pot. So, man, I didn't realize I'd be debugging the system here. Wow. All right, we'll continue on, see what else we can find. Maybe we'll find Sasquatch. Who knows? All right, I just thought I'd take a pause here and show you how crazy this stuff is to work on. So everything plugs into everything else on these boards. So for instance, this bottom board, which is your tone control and volume and all that, if you notice, it has these like sockets, and in order for you to remove the board, you have to first loosen this upper board, which has these pins that plug down into it. Same thing down here, this switchboard down here. This bottom row is actually pins that plugs into the board with the phono jacks, which or with the headphone jacks, which you can't, or microphone, that might be the microphone, I can't remember, but you can't get this out unless you unplug it from here, which you have to loosen these, but these won't come out because the other end of this board is plugged into the board on top. So everything links everything together. So you have to kind of one at a time take everything out, and then you have to kind of reverse the process to get it back in. So just thought that'd be interesting to show you. Well, it's another day, and regardless of whether I'm talking about Celsius or Fahrenheit, it's below zero out. It's actually 9 degrees below zero Fahrenheit, and the wind chill factor outside is negative 30 some degrees below zero Fahrenheit. I don't know. So really cold out. Just a quick cold pass coming through for 2 days, and then it's going to warm back up a little bit because of the polar vortex, as they call it. So anyway, I have about an hour to kill this morning before going out to work in the frozen tundra. So I thought I'd get started on removing the tuner. And I thought this might be a little bit interesting for some of you who are going to work on one of these. There are 5 screws holding this tuning module in. The way I remove the dial cord so that you don't lose the stringing is I just tape down all of the cords so it can't move on this end. Then I put around the circumference a layer of tape just to hold it onto the reel. Then I just gently loosen the 2 set screws. This slides off, and then I just zip tie it to the frame out of the way for right now while I work on this. And I will only leave this off long enough to get the tuning module cleaned and put back in. Now, removing the tuning module on this, the gang, is not very hard. It's just the wiring that gets a little bit crazy. There are 5 screws, and 4 of them are on this side. So there's 1, 2, 3, and 4. And yes, there is yet another ground ring. Talk about a stereo that is not star grounded. There are grounds all over the place. But what I will say that they did manage to do was this metal plate down here is a standalone plate. It's completely separate from all the other parts of the receiver. And that is kind of like your ground plane, if you will. Everything that's grounded is grounded through this plate. So even though it's not a star grounding system, and again, we're not dealing with RF grounds, we're dealing with audio path grounds and voltage, DC voltage grounds. So it works, but you really have a lot of connections to make sure are good. You know, any one of those grounding rings comes loose and you have the potential to induce noise into the circuit. So you really, when you put this back together, you want to make sure you have nice clean contacts on the rings and on the, you know, on this chassis, so that when you screw it down you get a nice ground contact. So you can see here's another one that comes off. Then there's one screw in the center on this side that comes out. I don't know if you can see it. And mechanically this will be ready to come out. But now we have to remove, there are a couple of individual wires, and then there are 4 coaxes. So you have one here and one down there. And then on this side you have 2 more, if you can see them. I hope I got them in shot. And they're wire wrapped onto these wire wrap posts. So now the way I deal with them is I will use a wire wrap tool, and I have several different ones, but here's one, and you can order them online. Here's the part number for this one if you want to look for one. These are the more expensive ones. They cost a little more because they have a little spring-loaded sleeve, and the whole purpose for that is this will slide down over the post, and you can see the little machined prong on the end, how it looks. And it'll grab hold of the end of the wire and uncoil it, but it'll keep it all in a coil inside this tube. And then when you pull it out, you just use this and it pops that little coil out, and you can actually slide that coil back over top of the post when you're ready to reinstall it, and use a pair of you know, needle nose type pliers. I use a little thicker set than this, and you can just kind of wind them back on there. It's not going to be the same as a wire wrap tool to wrap it on there, but it'll put it on there tight enough that you can put a dab of solder, and it makes it look just like factory. It's perfect. A lot of times, for instance like this, you really don't want to stress these wires. You don't want to work hard in them and get them brittle so they break, because a lot of times if you look at the length of them, you really don't want to have to go stripping them back and so forth. So that's one way to do it. There's other tools that do the same job that are less expensive, but they just don't have that little spring-loaded tube on the outside, and they work just fine too. And if you have the touch with them, you can unwind the coil the same way and slide it off. So the idea is to take your time and be careful with it. And I'll show you how to use this one on this top one here. So if we take this and we go like this, and I'm working around the camera, hopefully this will work for me, and then you just slide it right off, and then you push the little popper, and there it is. And you can see the coil is still intact, and I can zoom in a little bit, and you can see that you can actually, if my camera will quit shaking, and then this can be slid right back on here and tightened up with a pair of pliers. Then you can get your fiberglass brush while you have it out, and you can clean this off. I'll go all the way around the pin and clean it, and you can see how shiny it makes it. It'll be ready for a dab of solder, good as new. So that's what we're going to do. I'm going to take this out so I can clean it properly, and then I'll reinstall all these wires, and we'll be back. Okay, so we have the tuning capacitor back in place, and everything's working, and you can see Very good. Works just fine. Now before I move on, I want to make a quick comment on these air variable capacitors, or the tuning gangs. And that is that whenever you go to clean one of these, sometimes they'll get dust or build up in them, or they might get a little bit tarnished or something, and you may kind of want to spray them out. Now there is specific cleaner out there. It's harder to find today than it was earlier, in the earlier days, but it is actually called tuner wash or tuner cleaner. And some of that stuff you want to make sure, like I use this. This is a contact cleaner, and it's actually for contacts, but it works well for this. The reason being is it leaves no residue, and it's plastic safe, and it's very quick drying, and there's no water in it or anything. The most important thing is no residue. These are air variable capacitors, not oil variable. And one of the mistakes that I see sometimes is I've had tuners come in where the owner or a previous service company has worked on the tuner and actually sprayed it with something similar to this, like deoxit. Now deoxit is called D5 because there is 5% of the deoxit formula in there with the cleaner, and it's designed to be left behind. That type of cleaner is designed for switch contacts, potentiometers, things like that, where there's actually metal to metal contact, and it lubricates and prevents corrosion. That's why deoxit is so popular. The problem is when you spray a tuner with that type of chemical, anything that leaves a residue behind, you're actually changing the capacitive value of that air variable capacitor. And you're going to find that the tuner is going to be way out of alignment, and that you can't align it because it keeps drifting around as the oil and everything in there is moving around, or as it dries and so forth. So you want to make sure that whenever you clean an air variable capacitor, you leave nothing behind. No residue, no dust, nothing. Because that will affect the capacitance of that tuner. And the only reason I say that is I have seen these come and they were soaked with deoxit or some other form of cleaner that actually had a residue left in it, WD-40 or whatever. You know, people will spray these trying to loosen them up or try to lube the gears up here, and it'll get down in there. Anything that gets on there will affect it. So just a little tip there when cleaning these. Use something that leaves no residue. Another good thing, now this one has the RF front end board in there with all of your dual gate MOSFETs and so forth, so there's some delicate components, but you can just take the tuning gang itself in a lot of cases, and you can drop it into a you know, like a bath or an ultrasonic cleaner or something with mild cleaning detergent, as long as it leaves no residue, and you can clean them that way and they come out looking brand new. It's a little more work to take everything apart, but you can do that. But the idea is not to use any chemical that will leave anything behind. So there you go. Well, it's all back together. Quite a bit of work, but we got the modules back in and everything plugged together. It looks really good. Heaven only knows if it works though. So this one's going to be kind of tricky to bring up, and I don't, with this much work done on it and the fact that it was so tore apart that you couldn't really test it between each process, I'm not holding out a lot of hope that it'll work first time plugged in. You never know, it might. But maybe I'll go through that with you and kind of show you the process of very, very carefully bringing something like this up. So let me get some things set up and we'll be back. Okay, we got everything set up. And here's what I have. I have the dim bulb tester in line. I have both of the main power leads here and over here for the power amp disconnected, so there's no high voltage DC rail, no plus and minus 90 volts on that. We're only running the preamp and so forth. So we're just checking this main power supply board. We know that our plus and minus 90 volts are correct because we tested that on the bench. We also know that this somewhat works. We tested it without a load on the bench. But now we have everything connected, and we just want to go through right now and check our plus and minus 31 volts and our plus 13 volts. Those are going to be over here, and I'm going to try to do this around the camera. The other thing is, because the dim bulb is in line, I have the soft start resistor jumpered out, as you can see down there. Now again, doing this sort of thing, you kind of have to know what you're doing if you're going to do this. In some designs of amplifiers we do this, in other ones the soft start circuit can't be bypassed this way. But right now the actual dim bulb is being our soft start circuit. It's a high enough wattage that it should trip the soft start relay, just to prove that that circuit works. So we should hear it click in after a while. And it's small enough of a bulb that if we do have a problem with the short, it should take up the excess current and limit the current to the amplifier. So it's a pretty safe setup right now. Hopefully everything's going to work. So we're going to flip the switch, and the main thing, I don't know if you'll be able to hear it through the microphone, but the thing that we're listening for is that click of the soft start, and we also want to see the dim bulb dim way down after the big caps charge up. So I'm going to move you first over to the dim bulb, and you can see it right there in the middle of the screen, kind of. We're going to turn the power on, and we're going to listen for that click. So here we go. There it goes. And you can see it's dimming way down now. So that's good. We're now going to move over to here, and we're going to measure. Hopefully I won't short out reaching around this camera. We're going to measure our voltages. So here's our first one. This one should be about 13 volts. So right here. And there it is, 13.03. 31 volts is negative 30 is the negative 30. So it'd be around 30, 31. This is our positive. And there's your positive 30. So pretty good. And remember, these are going to be a volt or two low because the dim bulb is in the way. But that's okay. We don't care about that right now. So this is all really good news. Okay? So now we pretty much know that everything's powered up as we speak right now. The front lights are on. Should be able to see them. Yeah, we can see them lit up. So far so good. The amp is powering up. It's not drawing any kind of excess current. Idling very nicely. Everything's running cool. So the front end of the amp, I'm pretty safe to say that it's okay. So we'll shut this off. And the fan is turning. It's turning nice and quietly. You couldn't even hear it. So our fan is working well. So what we're going to do now is we're going to discharge our main filter capacitors because they are holding a charge as we speak. I am then going to statically measure the resistance from each of these leads to ground, the positive and negative, and compare the two channels to make sure they're the same. And then we're going to connect our channels and slowly do the same process, bringing power up to the amplifier. Okay, it's another day. I can only work on this thing in little bits and pieces because of work and everything, but it's the weekend now, so I got a little bit of time to put on this. And where we left off last time, which was just a split second for you, was we tested out the low voltage power supply. It all looks good. I now have the DC power rails for the amplifier connected to both channels, and right now I have 2 meters. Our 2 meters are connected to the test points for the bias. So we're kind of going to use that bias as a gauge along with our dim bulb to see if everything is correct with the main amplifiers. So theoretically, if we turn this on, I still have the soft start bypassed, and we're going to use the dim bulb as the soft start. It's also going to be a current limiter, and I'm going to use the intensity of the bulb along with our little kilowatt unit here, to kind of monitor what kind of current draw we're having with the amplifier. If there's something wrong with the amp module, we'll see it because the amp won't bias up properly and the protect relay won't come in. I think this thing idles at pretty low current. It idles at about 115 watts is the spec on this. So when everything's working properly and there's no current limiting in the AC mains, this amplifier should stabilize at about 115 watts of idling power, with no signal, with the volume all the way down. So we're going to kind of check that. Now that's going to be skewed by the actual light bulb itself that we have, our dim bulb. So it'll be below that. But the bulb should dim way down, almost go out once everything settles. And you should see adjustable bias on these two test points here. So your bias test points are actually on these two little connectors that go down to each channel. So that's how we're connected, TP1, 2, 3, and 4. So let's start out and we'll turn the power on. And we're going to look at our dim bulb and see how everything comes up with all the power and all the connections made now. Okay, there we go. So the protect or the soft start relay did pull in, meaning our voltage got up to the correct level. But if you take a look here, our dim bulb is relatively bright. It's not full brightness, so there's no shorts. By the way, before I did this, I statically measured from positive rail to ground and negative rail to ground on both amplifier modules, and they all matched and they all read a capacitor. Essentially, they were high ohms, in the tens of thousands of ohms. So I'm pretty confident that there's no shorts here. Looking up at the meters, it's not so good. So this channel, which is the channel that's the closest to us that we're looking at, you can see we have bias, and in proper alignment this thing should bias at about 50 millivolts on this test point, and we're getting about half of that, or a little less than half, and that's to be expected with this dim bulb being the way that it, being in the circuit. So that's good. This one, however, is dead. You have 4/10 of 1 millivolt. Pretty much the that channel is not biasing at all. So there's something wrong there. And that's probably why this bulb is so bright. And I would also argue that if we took that bulb out of the circuit, we would be blowing fuses or shorting something out. So I'm glad that bulb's in there. So probably a self-induced error. Again, there's a whole bunch of work that goes into restoring these. So now we're going to try to troubleshoot what's wrong in here. We could have a capacitor in backwards. We could have a faulty transistor. We could have a loose or shorted wire. Any number of things can cause that. So let me turn this off. And the first thing we're going to do is we're just going to disconnect the main DC rails from this channel and see if this channel will come up and work and if our protect circuit will come in. So that's our next test. Okay, I have the one channel disconnected, and remember, before, a couple notes here. Off camera I did try to adjust the bias on this channel and it does not adjust. It's kind of weird. It'll go up to maybe a little bit, just under 1 millivolt, and then it'll start dropping back down as you rotate the pot. So there's something definitely strange on that channel. On this channel, if you remember, it was working, and I can adjust the bias on it. The bias pot works as advertised. So hopefully what we're going to do now is see if the amplifier will come out of protect. And again, I didn't really study this protect circuit up here. It may need both channels to come out of protect mode, but that shouldn't stop the amp from not drawing excessive current. The other thing I did was, in the dim bulb socket down here, I have a fuse holder, and I can change different fuse values. I have a small value fuse. It's only 2 amps. which is more than enough to achieve that 115 watt idle current, because that's actually about less than an amp or around an amp. So we have twice that much. So if something should go wrong, we're going to turn this on, and then we're going to go into full power and see if the amp will come up on one channel. If something goes wrong, we have our fuse for backup, so we have protection here. And you can see we're disconnected on this channel. And the only difference before we were running this on full power is that we just had those two power leads, you know, the main power rails disconnected from the amp. So kind of just going through this in a logical progression here, at least logical to my twisted mind, I guess. All right, so let's check this out and see what happens. So caps are charging. Soft start relay comes in. And we still have what I think is way too bright of a bulb. We're drawing about 32 watts, which really doesn't mean anything because the bulb is limiting, but it might be okay. So what I'm going to do now, I have bias. We're using the bottom meter, sorry. See, that's what I did. I hit a button. Let me reset it. Here we go. And we have our bias. It's sitting at about half where it should be, which is good. So I'm now going to switch to full power, and we're going to see what happens. And we're going to watch this watt meter and see what happens. Boom. Okay. We popped our fuse. So obviously it's not happy with this channel either. So then now what we're going to do is we're going to disconnect power from this, go back where we started, make sure everything still works properly as it did before we started with the amplifier here. So let me get ready to do that. Okay, we're back to how we were. Now remember, guys, I mean, I'm showing you here as I'm doing this. Again, this is the kind of thing that goes into anytime you work on equipment like this. When you do an extensive amount of work on something like this, more than just replacing one component or something, you really have to, there's a high probability that you can get something wrong. It happens, you know, and anybody who comes on the comments and tells you that, you know, that you're just not careful with it, they've not worked on equipment a whole lot. Because once in a while you're going to have this. A lot of times you don't, but this is why we do this. So there could be something wrong with these amp modules, and I'm going to walk through it with you on how I troubleshoot things. So we went back to how we were. So we have both of the power leads disconnected from the amp modules. Everything else is totally connected. And we're going to go back and turn on the power through the dim bulb, and then we're going to switch to full power again. Once again, I have another fuse in here, so we're good with the fuse. So let's turn this on and see what happens. And there you go. And you can see now the bulb dims way down, very dim, like it should. And I have a feeling now if we go to full power, and we're still drawing about the same amount of wattage. You look, we have 33 watts through the dim bulb. So once again, not a whole lot more power being drawn at that reduced voltage. So let's go to full power. And what do you know? We had a little surge up to 80 watts, of course, as the caps charged the rest of the way. And now we're sitting at about 56 watts, which I would expect. So it's less than half, a little bit less than half power for what it's supposed to idle. So it should idle for about that much more to get your 115 watts with the amp modules. So the amps should really idle at very low current, and they're not. So, and again, everything's looking just fine. The dial's lit up. The tuners looks like it's on. Everything's working. So again, we still have something wrong in our amplifier module. And now what I'm going to do, just for giggles, I'm going to hook this side back up and test it like that. Okay? And again, if you don't like going through all this, is too slow for you, skip through. Doesn't matter. But I just kind of want to go through this for those of you who want to work on things like this. Okay, so now we have this channel connected up and this channel disconnected, even though this one, if you remember, was the one that didn't really want to come in very well. We're going to power it back up with the dim bulb. I have another fuse in, and we're going to see what we get. So far, so good. And now that the other channel is disconnected, this one woke up, and look at that. We have some bias on there. So since the bias is not high, it's actually way lower than the 50 millivolts they're looking for. Let's go to full power and see if we blow our fuse again. Look at that. And we're idling right around 87 watts. And our bias is about half. It's 26. So I'm going to adjust the bias pot just for the heck of it. And let's see if it'll adjust. Look at that. If I can keep the tweaker in the pot. Here we go. Look at that. I'm going to turn it down just a little bit. I'm going to keep it around 45. And but it works. So this channel looks to be good so far. Now, it's still not pulling in the protect relay, but I have a feeling that both channels, this is not a normal protect circuit like you would see in some of the lower end amps. There's a lot more going on for monitoring and so forth. So with the other channel being out, I'm not surprised the protect relay is not coming in. But this side here is good. So really what we have to do now is we have to take a look at the other channel and see why it's not working. If you remember, it was biasing. Part of the thing is my fuse might be too small for the surge current, because when this amp first comes up, it draws a big surge for a split second, and then it's okay. But I don't know. I mean, this side didn't blow the fuse. The other side does when it's connected. So let's look a little deeper into this and see if we can figure if it's just user error or if there's actually a problem with the amp. Okay, so here's where we are. We have both channels connected now, and there's definitely a problem on this channel. And the reason I say that is I can get it to not blow the fuse if I use the variac and bring it up very, very slowly with the variac. Here's the problem, is that both of the adjustments for the offset and bias, they work, and they work well. They have a lot of adjustment in them. However, as I get the power, the voltage up to around 70 volts, 60 or 70 volts, the bias starts to go above what it's supposed to be idling at. And the DC balance stays good, but the bias goes way too high. If I go beyond the 70 volts or so, the bias will go way up, and obviously there's something wrong. There's an imbalance somewhere or something in here that's not correct that's causing that. So we really have to troubleshoot that, because the pot is basically maxed out in the one direction, and we still don't have enough adjustment. So that tells me that there's probably either a transistor that's not correct in here or something like that, which is entirely possible. Now, when you replace transistors, a lot of people who want their stereos restored want the small signal transistors replaced because they have a tendency as they get older to get noisy, especially if they've been in a damp environment like in a basement or something for a long period of time. Anything's been splashed, if they got wet or something like that, those small transistors will tend to get noisy and leak. So as a precaution, a lot of people, when you're restoring their receiver, they want those transistors replaced. One of the negative things when you get into that is the original ones that were made in the 1970s are no longer being manufactured, and there are plenty of actually higher quality replacements out there, but you have to find the right one. And just Google searching things and getting charts and part lists from the internet isn't always the best way. For instance, this particular amplifier has a lot of I believe they're 2SA733s, and a 2SA733 is a PNP small signal transistor, high gain, low noise, and the common replacement, one of the common replacements that's recommended is the KSC733. A lot of the KSC series are pretty close matches to the original 2SC and 2SA and so forth. I'm sorry, KSA. So a KSA 733 would be an equivalent to a 2SA 733. However, if you look the specs up on both of them, the earlier 1970s versions of the 2SA 733s, and again, there's letters after that that actually indicate what the gain of the transistor is, what the pin configuration, different things like that. But just in general, 2SA 733s from the 1970s are a 625 milliwatt dissipation transistor. The KSA 733 is only a 250 milliwatt or so. So it has a lot lower dissipation. And what that means is when that transistor is biased with a little bit higher current on it, the 2SA 733 will work just fine. The KSA 733 may get noisy, may break down, may even short. So you really have to be careful when you're picking transistors. And even when you get a proper replacement, it is possible that the one you have, the one you're putting in may have some issues. I've had that. I've had brand new transistors that I purchased top quality from a reputable place like Mauser or DigiKey or whomever, and put them in and they didn't work. Threw them away, picked another one out of the pack, put it in, it worked perfectly, never had another problem. So transistors can be finicky. Just keep that in mind. And you do have to look for things like transition frequency. That's technically the frequency at which the transistor will have unity gain. That sometimes having a higher frequency spec'd transistor is a bad thing in these old receivers because the higher frequency transistors will tend to oscillate at high frequencies. Whereas if you have a transistor with a lower transition frequency, they won't oscillate at that high frequency like that. So again, you could induce a problem by using replacement parts if you don't know what you're doing. So you always have to go through this and check everything carefully to make sure that you have the right part and that it's working and it's happy with that circuit. So this is part of the process. It's just, you just have to do that. If you're going to get into this, you're going to run into this once in a while. Some circuits are way more forgiving, that you can pretty much put a lot of different variable transistors in there and they work just fine because of the way the circuit's designed. But other circuits are not designed that way, and they have to have specific values in there. So I just thought I'd share that with you. And so we're going to look at this a little more closely, try to get it down to the component that's causing our problem, and get it fixed. Okay, so I took everything out, the whole amplifier module, just removed it, and compared both boards statically, and they matched absolutely perfectly. So I started checking around, and really all it ended up being was that the bias pot was actually no good. And it was a brand new bias pot, but it was just kind of flaky. So I took it out and I replaced it actually with one that we can adjust from the side on this side, because I think that makes more sense than trying to adjust it from the top. It was really hard to get in there. So actually that was a good thing. And I put it all back together, and I think we're going to be okay now. So everything's plugged in. I got rid of the dim bulb and I got rid of the variac. I don't think we'll need that anymore. Everything's looking good. And when we turn it on, everything works just as it's supposed to. And we can see our bias is coming up as it warms up, and it'll stabilize in the 30 to 40 millivolt range. I have them both set a little bit low on purpose. And you can see we are now idling right around that 100 watt range. And actually, my line voltage is way down today. We're only at 114 volts. I normally have a good solid 125 volt line here at the house, but being that it's winter and there's so many furnaces and space heaters and everything throughout the neighborhood going on, our line voltage is a little bit low today. So that attributes to it a little bit. But anyway, you can see it's holding that 107, right around that 115 watt range where it's supposed to be. And the only problem that I've noticed now is that the muting relay is not pulling in. So we actually have to troubleshoot that now. Now I checked for DC on the speaker terminals, and there is absolutely none. The DC offset is absolutely perfect on both channels. So I have a feeling there's something weird going on with this board. Now all I did to this board was put the new relay and the one capacitor. I didn't touch anything else. And there may be something flaky with that transistor or something like that. But we'll check it out. Okay, I have the amplifier powered up, and I just want to see if there's any voltage on the relay coil itself. So the coil is these two terminals right here, and I have nothing there, and I have nothing there. Now if we look on the schematic, we can see right here is where we were reading across this coil, and I'm not getting anything. I'm going to measure the 3 base emitter and collector of this little transistor. So that would be right down here, and looks like it goes base, collector, emitter from the top. So here's the base, and there's negative 80 volts. That doesn't seem right. It's 80.8. Emitter is 81.3, and collector is negative 81.5. So there we go. Now let's see if that's what that's. I don't think that's correct, but let me take a look at it and see. Well, you know what they say, stupid is as stupid does, and I'm wearing my idiot boots right now. So if you look at the relay, I stared at this 10 times and then it just hit me like a ton of bricks. The relay's in backwards. I'll just cut to the chase. This is your speaker outputs right here, and these two, the orange and the green wire, are your speaker inputs. They're coming from the amplifier. And if you notice, these open contacts right here are going to where the coil should be, and the coil is where the speakers should be. So this relay needs taken out, flipped, and put in the other way. The reason being is the way these are configured. Normally, the coil is actually spaced. The coil pins are a little bit further back than the spacing between the contact pins. But if you look on these ones, they're all equally spaced. So you can actually put this relay in either way. So what I need to do is remove this relay, flip it, and put it back in, and I bet you it's going to work. Okay, now we have the relay in right way around, and I cleaned up the board, put a fresh coat of conformal coating on it. I did take the transistor and the diode out to test them, and they tested good, obviously. But while I had them out, I noticed that this transistor has really badly tarnished legs, and they actually are kind of brittle. I'm afraid they're going to break off if I put it back in. So I'm glad I actually removed it. This one I tried to clean the tarnish off of the diode, but it was pretty bad. And, you know, a diode is pennies, as is that transistor. So I replaced them. I put a 1N4007, although I probably could have used a better diode, a faster diode than that, but for the flyback diode, but it should be just fine. And then I put a little heavier transistor in there while I was at it, because those are notorious for going bad on those relays. So this one will never fail. It's a 300 volt, rated at a half an amp or so. It's pretty good rated thing. So let's see if it works. Turn it on and see. Everything's plugged in, and here we go. Okay, soft start. Oh, there it is. So the protect circuit came in. Everything is up and running. The amplifier is biasing properly and has good DC offset. I think we're ready to see if it makes sound. Wow. So there you go. Man, does this thing sound amazing. Wow. I didn't expect it. I mean, I knew what Marantz sounds like. It has a warm, but I never thought it would have that crystal clear sound, like the old married couple. Because you know how I always say I really, really like the sound of that Pioneer SA9100. This one bests it, I think. This beautiful sounding amplifier. I've never heard one of these in real person because they're so rare. Boy, oh boy, is this thing nice. So you might think we're done, but we're not. We have a lot of testing to do, and even though it looks really nice and clean on this side, it is really grungy and gross on the tuner side. So we're going to have to do the alignment of the scope. It works, but I'm going to want to align it so that all of the functions line up to the center of this monitor together. And we're going to have to do the recap and the restore on the tuner, clean it, and right now it doesn't look like it needs a whole lot of alignment, but I'm sure it can use some touch-up. Everything else is ready. So this is going to be the end of this video here, this clip. Part 3, I think this is. In part 4, we're going to tackle the tuner, align the scope, and then do a final total test on the system, and maybe hook it up to some really good speakers and listen to it. So again, thank you for coming with me on this. As always, I wish you all peace, joy, happiness, and good health in your lives. And even surprised myself on this one, I guess. Even though we made a few mistakes, we had to replace had to flip around the relay, and we had to replace the potentiometer on the one channel. But other than that, first try, everything worked. So not too bad. We lucked out once in a while, huh? All right, we'll see you next time, and take care. We'll see you soon. Bye-bye.